And for the first speaker is Professor Masahiko Harata from Tohoku University. And I would like to briefly introduce his CV. And Professor Masahiko Harata graduated from the Department of Biology, Faculty of Science, Tohoku University. He is now a professor at the Graduate School of Agricultural Science. His original research here has been molecular and cellular biology. And he now aims to apply the synchrotron light to life science and agriculture. He has established the Center for Agriculture and Life Sciences using synchrotron light to facilitate the usage of NanoTerasu. So the title of his talk is Towards the Utilization of NanoTerasu in Agriculture. Professor Harata, please.
Thank you very much for the kind introduction. And we were sorry that the talk was changed because of the original speaker's health conditions. So anyway, as Professor Tada mentioned, I'm originally a biologist, molecular biologist, but not a synchrotron radiation scientist. So I will not talk much about the science today, but I will simply talk about the collaboration between synchrotron light and agriculture. Indeed, the usage of synchrotron radiation facilities in agriculture might not be our major focus to date. However, we believe that now NanoTerasu will offer some advantages and new examples for agricultural use. So one of the advantages of NanoTerasu is its location. So this is a map of Japan and also location of the synchrotron radiation facilities in Japan. And before opening NanoTerasu, all these synchrotron facilities are located mostly in the western part of Japan. And NanoTerasu is the first synchrotron radiation facility in this area. We call this region Tohoku region. And indeed, our name of university comes from this Tohoku region. And the Tohoku region is known as a major food supplying area. And of course, we supply many agricultural products, including rice, livestock, and fruit and seafood. And also, this area provide very good sake. And so please enjoy these agricultural products during your stay in Sendai. So anyway, NanoTerasu is located in this agricultural area of Japan. So therefore, researchers, companies, and local governments expect to use NanoTerasu in agriculture. So the local location of NanoTerasu in Tohoku University campus also provide an advantage for agricultural use. So this map shows the campuses of Tohoku University in Sendai City, and this blue-colored area shows the Tohoku University campuses. And this Aobayama new campus is the newest campus of Tohoku University, and the NanoTerasu is located in this campus, as you know probably. And this campus is connected to the central JR station of Sendai, and it's close to this lecture hall. And this NanoTerasu, if we use a subway, then we can easily access to this Aobayama new campus within 10 minutes. And therefore, researchers and the company staff, local government staff, and also farmers can easily visit NanoTerasu. Furthermore, NanoTerasu and our department, the Department of Agriculture, are closely located in this Aobayama new campus. So this is an overview of NanoTerasu, and this is our building of the Department of Agriculture. So it is obvious that our department is very close to NanoTerasu, and indeed it just takes 10 minutes on foot from our department to NanoTerasu. So this proximal location of NanoTerasu enables the cooperative use of agricultural facilities and equipment with NanoTerasu. For example, animal facilities and glass houses for plant, and also food, for example, food processing facilities are available together with NanoTerasu. So we will now utilize these facilities together with NanoTerasu. And from an advertised aspect, from an administrative aspect, our department established ASYNC in 2019. And ASYNC is the abbreviation of Center for Agriculture and Life Sciences using synchrotron light. And I'm in charge as the director of ASYNC, and more than now, 30 members of our department participate in ASYNC. And we aim to utilize the next generation synchrotron NanoTerasu in the field of agriculture and life sciences to facilitate academic activities and industry-academia collaboration. So on the other hand, probably as you realize, most members of ASYNC are not synchrotron radiation scientists. So therefore, we need to tight relationship with SRICE. SRICE is a department, the facility, SRICE belongs to Tohoku University, and SRICE is the abbreviation of International Center for Synchrotron Radiation Innovation SMART. And this center is established in 2019. So SRICE consists of 3 divisions: the cross-fertilization division and the SR core research division responsible for the synchrotron radiation science in NanoTerasu. And this division, innovation and fertilization technology transfer division, is responsible for somehow applying the synchrotron radiation techniques for education, research, and also governmental and industrial usages. And there is a laboratory named Agriculture Food Smart Laboratory. And some of members with ASYNC, this is our department center, and some of members of ASYNC participate in this laboratory. So this kind of tight relationship between SRICE and ASYNC is important for the activities of ASYNC. In the usage of synchrotron radiation light in agriculture. In the next part of my talk, I will introduce some of the activities of ASYNC. So NanoTerasu is just open in 2024. Therefore, end stations have not been fully optimized for food and agricultural materials. Biological materials. Biological materials are quite sensitive, for example, for temperature and conditions. So to treat this kind of biological materials, food and agriculture product, we are trying to improve the end stations. This is the example of BL09W beamline for phase contrast CT imaging. So we have designed a sample holder to measure frozen samples. And the phase contrast X-ray CT imaging is available with this detector located 1 meter apart from the sample. I just show one example of phase contrast X-ray CT imaging of frozen mouse muscle. And we can visualize the 3D structure of mouse muscle fibers. And this kind of structure is quite useful to evaluate the tissues of animals and also evaluation of edible meat. And of course, mouse meat is not edible, but we are now trying to measure the edible meat. And also, we are now interested in the changing the structure after cooking or after the enzyme treatment. And our group is now developing coherent diffraction imaging, named tachography. So X-ray tachography is expected to bridge this observational gap between X-ray microscopy imaging and TEM. So with this technique, now we are trying to visualize the fine structure of food and agricultural product. I will show one example of kamaboko. Kamaboko is one of the local specialty in Sendai area. Do you know sasakamaboko? But anyway, so kamaboko is a Japanese traditional food, and probably the word surumi is more famous in foreign countries. And this kamaboko is characterized by elastic texture. And this elastic texture comes from the mesh-like structure, supposed to come from mesh-like structure of actomyosin extracted from muscles of fish. So X-ray tachography can visualize the meshwork-like structure of actomyosin under a non-vacuum environment. So we believe that developing this kind of technique will help evaluation of fine structure of food and agricultural product, and also biological tissues and biological cells. So, and we have already started evaluation of the local specialties of Tohoku region, and including oyster and sake. And in this area, produce very good oyster and very good sake. And now, indeed, now it's the best season for them. And please enjoy the combination of this oyster and sake during your stay in Sendai. And this is the best season, indeed. So anyhow, I just show a few, just small number of examples of the analysis of this oyster and sake. And as you realize, this is a XRF analysis of oyster, and we compare oyster from Tohoku region and oyster from another region of Japan. I didn't mention about the region of this oyster, but anyhow, we compare these two oysters, and in my comparison, but I do not know this is generally true or not, but in my comparison, the oyster comes from Tohoku region seem to contain rich minerals, especially in iron. So of course, we will continue this kind of evaluation of local specialties of Tohoku regions. And in this slide, this is a scattering patterns of various sake of this region. And we compare, I just show just one result. So that we just compare the scattering pattern of sake. And these sake are brewed in one company, but the diffraction pattern are so diverse. So we didn't expect such diverse diffraction pattern of sake. So now we are trying to make a relationship between this scattering pattern and the taste of sake. And but it takes time. Well, so sake analysis itself does not take so long time, but testing takes time. So anyhow, yeah, we are trying to somehow make a relationship between this scattering pattern and the taste of sake. So anyway, so in the last part of my talk, I will introduce our effort in international networking. International networking is one of the mission of Async, our center Async. And this is one example, and we had an international workshop soon after opening NanoTerasu in 2024. The workshop is named Synchrotron Light for Future Foods. The interpretation of future foods is very difficult, but anyhow, so we wanted to apply synchrotron light techniques for developing and evaluation food and agriculture product. And we invited speakers from Canadian Light Source, Max 4 in Sweden, and Taiwan Light Source. And also our members did give talks, and we had very discussion with the speakers and the participants. And also, this is the last slide on my talk, and now Async plan to join the international network named PALSAR. PALSAR is abbreviation of Partnership for Advancing Light Sources for Agriculture. So last year, 2025, we had a meeting named PALSAR in Canada, and this meeting was organized by Canadian Light Source. And we enjoyed this meeting very, very much. And at this meeting, we discussed our international networking with guests from, of course, from northern part of North America, South America, European countries, and Australia. And now we aim to expand our international network to all these areas of the world as a member of PALSAR. And I will close my talk, and thank you for your attention.